In a previous video, we looked at the data definition language sort of applied to sort of a single attribute. And here we're going to sort of move on and look at tables, keys like primary keys, candidate keys, foreign keys, and so on. So we defined previously the attributes and gave them identifiers, names, and types and domains, and said whether they were could be null or not, whether they had a default value or not, and so on. Now we're going to collect these attributes together and define a table. So we're bringing together the previous things and calling them a table, and then we will pick out a field or a column property attribute. Um, we're going to pick out some of them to play special roles like primary key, candidate key, foreign key. Okay. As we sort of know, we've been playing enough now that the a primary key is used to identify a record within a table or relation. The primary key cannot be null. It can be a single column or it can be uh, a composite. And if it is a composite, then none of the fields can be null. And this is entity integrity, that we must be able to uh, identify an instance of an entity uniquely, that I can give you a primary key and know that there is one and only one row, and then every row has a primary key, one and only one. Okay. So there are, of course, specific words in SQL to designate that. So sometimes you can, in the definition of your table, just follow the property and its type with the keywords primary key, or you can give your full list of all the attributes and their types and so on. And then at the end, say primary key in parentheses and the field, or in the case of a composite, primary key fields that are going to serve this purpose. There are, in many situations, what we call candidate keys. Uh, a field or another field or a combination of fields, field, attribute, property. I'm going to use these terms interchangeably, which could have played the role of the primary key. It wasn't chosen to do that, but it could. So it could be uh, a social security number and an employee ID. Like they are both, we must have them and they're unique. And so it could have the same, it could play the same role as the employee number. We're not choosing to use it as a primary key, but it could serve that purpose and it must have the same properties as the primary key. Um, had an example where we looked at a table with tutors being assigned, and so we could identify a table by a the date and the time in the room. So where, or we could say the date and the time in the tutor, or the date and the time in the tutee. That these were all ways to pick out records of a particular table. And so we had a number of candidate keys. So we pick one to be the primary key. We chose date, time, room, but we know that the other combinations, the date, the time, and the tutee, or the date and the time and the tutor, must be filled in. They're not null, and they must be unique. And so we have a keyword in SQL to specify that, this unique keyword. Um, we also have certain attributes that play the role of foreign key. So we can have a relationship between two entities, And we can establish this relationship by, especially if it's a one-to-many relationship, by having a foreign key in one table match typically the primary key in another table. Sometimes there is, in the case of a many-to-many relationship, there is a separate table, I call it the bridge table, where sort of there are multiple foreign keys sort of establishing the relationship. So again, the foreign key could be null, and to say that the entity is um, not known to be participating in this relationship, or but if it does have a value, it must match a probably a primary key from another table. So, and this is known as referential integrity. So we had entity integrity for the primary key, referential integrity for the foreign key. And so again, SQL has this built into the language, and we use the keyword references. So we have an attribute references another field in another table. Okay. When you have a relationship between two entities, then you have to ask the question, what happens to the relationship when if I were to do something to the table? So, I make some change to my table with the primary key, and there's another table referring to it that has a foreign key that's referring to it. And what should I do? What if the primary key is updated? What if it's deleted? Does this affect the relationship? What should we do? We want to maintain refer referential integrity. So we certainly want to maintain it. And then the question is, how? And there are different possibilities here. One of them is to cascade uh, whatever we did to one, we do to the other. So, or we can set to null. So take the child and let the that foreign key become null, so that that sort of, I don't know, that parent may be absent now or changed some way, and so we'll vacate in some sense the relationship until it's sort of maybe vacated permanently or vacated till we figure it out. Um, or we could have, if there's a default value, we could set it to the default. So there is some like almost like a default relationship that you would have if you have no other. And then you can say no action, and not mean that I'm not going to do nothing, but that I'm going to sort of prevent the original action on the parent, uh, and sort of issue a warning, like there are children affected here. Um, and we can do different things depending on whether we are updating or we are uh, deleting. And so we can choose our actions, and we can choose different actions for update and delete. Okay. Another thing, constraint, a different type of constraint. So we have these uh, primary key constraints, we have candidate key constraints, we have foreign key constraints. We can have additional constraints known as enterprise or business rules, where we can just sort of say, because in the database, we're trying to reflect some reality. And so there may be some reality that is not a sort of built-in thing of all databases, but applies to the particular situation that is being modeled with the particular database. So an example here is uh, a library. So you have a patron, and they may have a limit on the number of books a patron can have out at a given time. So we want a way to be able to put this such a business rule into the database. All right. So that can be what that uses the keyword assertion. So we're creating a assertion. We give that assertion an identifier, some name. Here I use the name prevent too many books. And then we also have the keyword check. We've seen the word check before to make sure something's in a domain. So now we're checking an assertion and we're looking for, we have some table, presumably here we're saying books currently out. And we are sort of somehow counting the uh, the number for each patron, and we're asking that that count not be greater than 10. So there should be no IDs of patrons when we do the counting with the group by that is bigger than 10. So that's an assertion, that's a business rule. Okay. So putting all together, our where one of the main verbs of the data definition language is create. So we have different levels of things. We have the whole schema, which we can create, and also drop. We need to be able to undo things as well. Um, we can make domains for attributes. We can make them, create them, alter them, drop them. Tables we can create and alter and drop. And views. Views are like tables, but they are for limited like security reasons. So to to allow certain users to sort of to make a table-like object that certain people can view and but not have access to this sort of genuine table. Um, so all these things that you are creating in the data definition language go into an environment. You sort of collect these rules and definitions together to make uh, a catalog, and then you have all the so now we're talking about the schema, the large scale. So we have the individual create tables and create domains, and then we have relations between tables, and we sort of bring that all together, and that is the schema. All right, so here's just some definition. Some This is not a specific thing, but sort of more general. And typically here, square brackets is saying that something is optional. So we can define fields. We can make up a name, say it's data type. Does it have, is it unique? Are we allowing nulls or not? Does it have a default value? Does it have some domain constraint using a check? So that is one thing we do. We can establish, uh, and we do that for sort of all the fields of a table. Then, so there's like a repetition of that defining fields. So there could be many, many fields. We can specify a primary key. It may be one field or a collection of fields if it's composite. There may be candidate keys, so we can do unique, and that there can be more than one candidate key. So that's the sort of curly brackets there are representing a set of things. So there could be many fields we define at the top. There could be many candidate keys. And then we have our foreign keys. So again, it's square bracket meaning it's optional. We may or may not have foreign keys. And then the curly brackets meaning that there's possibly more than one. So we uh, can have multiple foreign keys in a table. And so we have foreign key in a list of tables and what they reference, and what we might do if we update, what we might do if we delete, and we might have business rules so that we check. So this is all just like a generic collection of all the things that might go into the definition of a table. And now here's just sort of a particular example. We're creating a bunch of domains. I think this is for like a renting situation. So we have uh, a number for the owner, um, and we're defining a domain for that and checking that it comes from a particular table, creating a domain for the staff number, property number, a number of rooms, and sort of a rent for the property. And so we have all of these domains defined so that we know that our data going in has, proper values. And then we're going to pull these together so we can use those domains now as if they are types. So we're creating a table called property for rent, and uh, property number was a P number defined previously, and we're saying it can't be null. And the number of rooms is a P room domain defined previously. It's not null and it has a default value of 4. The rent is a P rent type defined in the domain previously defined, and it's not null and a default value of 600. This is an old thing. 600 rent is probably cheap these days. Um, Owner number, same thing. Staff number, um, and we're applying some constraints, some business rule. Um, Branch number, and we define the primary key for this table, foreign key for this table. We're saying what to do if we were to delete a property, and so on. We need to be able to change a table. So, in case we don't get it right, we might, in altering a table, we might uh, add a new column, add a field, drop something, add a new constraint, drop a constraint, add a default, drop a default, all the sort of things that you might have. You should also be able to add them, drop them, alter them. And that there we have it. So we have our data definition language. We can make the attributes and say everything we want to say about attributes. Then we can pull the attributes together to make a table. We can relate our table to other tables with foreign keys and references and put it all together and make our schema. That's it for this one. Thanks for your attention.